So what were the goals that I started off with that I want to, so what, how I want to structure this talk. So first of all, I want to introduce, so I'm going to start from the very beginning. I want to introduce you to this field of computer vision and artificial intelligence. And whenever I can, I'll try to relate it with your curriculum and also give you some insights into how you can pursue this further at undergraduate level and later even as your graduate school, even in your graduate school. And other than that, I want to understand what are your goals, what are you curious about, and is there anything that you're expecting? So I'll make sure that I include that in my talk as well. So feel free to unmute yourself and tell me what you're looking forward to in this talk. If there's anything that you know about computer vision, anything basically. So I just want to start from the very basics. So when you hear the word computer vision, when you hear this term computer vision, so obviously you know what computers are, and you understand what vision is. So for humans, when we hear the word vision, so we talk about just looking at a scene of objects or something in an image, and then we are able to understand a lot more than let's say just identifying the objects that are there in the image. So for example, if I ask you to look at this image and I ask you what do you think of it, then there's a lot more than let's say identifying one particular object or identifying two people who are in the photo. You're able to understand that this photo has many things, right? So if you look, if you try to look, so there's a guy who's playing guitar, and there are two other people, and then from another perspective, you can say that on the left is an old woman, and on the right is an old man. You can also say that in the middle there's maybe a metal vase. So when you look at an image, humans are able to understand the image and identify the objects and understand the meaning of what's going on in that scene. So, but computers unfortunately are not that good at it right now. And as we build smarter systems, as we build robots, we want them to understand the world in the way that we do, right? So that's what we want to teach computers. So bringing together computer vision. So there's so much data that's around us. Why? So I want to talk about why is this field important. So of course, as I mentioned, we want to create robots and understand the photos. But like as humans, images are very important to us, right? And I'm sure we all click a lot of pictures. So there's so much data that's around us, right? There are so many videos on YouTube, and almost 50% of the world's population has smartphones now. You all might be using social medias, Instagram, YouTube, which are centered around images and videos. There's so much surveillance that's happening, and so much data being collected from let's say CCTV cameras. So like images and videos have always intrigued us, and we want to understand what's going on by leveraging all this data that's around us. Uh, I'll talk about some interesting applications of computer vision. So you guys might have heard about self-driving cars. So so now driving is a hard task, right? Even for humans, it takes some effort to get it right. And with so much data that's being collected, we can actually teach machines to drive even much better than humans. So machines are already better than humans. They're not out on the roads because we cannot afford even one accident in let's say a million drives. So we're trying to get better at it, and the way that self-driving cars have been modeled is by following how humans learn to drive. So if you see how humans learn to drive, so what we essentially want to do in solving this problem is that we want to replace the driver by a machine. Now if we try to break down this problem, then how do human drivers drive? So first of all, human drivers see the scene around them. They see these streets. They see the markings on the streets. They identify objects such as traffic lights, and based on so this first part is called perception. When you see the scene and you try to identify what is in the scene. So computer vision is very helpful in identifying the objects and all these tasks that I'll talk further in this talk. Uh, talk about further. Um, After you perceive what's in an image, all the objects in the streets and everything, then humans try to fulfill some goals, uh, such as planning a path. So, for example, if I have to go from point A to point B, let's say I have to take a turn at this intersection, then I will see what objects are there, what markings are there, and I'll plan a path according to that. In order to avoid the trajectories of other cars around me. And once I identify, okay, so this looks like the correct path according to the rules, and by avoiding other obstacles and cars, then human drivers give some commands to the car by using steering and gears to basically navigate in the way that they want to, in the desired navigation path. So that is how humans drive, and we try to take these individual tasks and try to model them with machines. So I just wanted to give you a brief overview about how scientists have gone about driving in the past 10 years. And I'm sure it's a very interesting area that some of you might be working in the future. Other interesting application of computer vision is healthcare. So I don't know if you guys are familiar with this Amazon shopping experience. So there's this Amazon. These are There are Amazon Go stores, uh, and you can actually walk into these stores, just pick up anything that you want and leave, and they would automatically bill you. So whenever you pick up something, the machine learning algorithm, the computer vision algorithms, they identify what you have picked up, how many have you picked up, and they automatically assign that object to your Amazon ID. Uh, yeah. By the way, I'm working at Amazon as an applied scientist right now. So I recently started in this role. So yeah, just giving an advertisement for Amazon shopping. Uh, so yeah, this is an interesting application, Amazon shopping, and in the future we can expect many more such applications of computer vision for commerce, for e-commerce, for commerce. Yeah. Let me move on to other applications. So sports analytics is another upcoming field, with computer vision algorithms, you can actually identify where the ball is, where the players are, and we can actually identify how many which players have made which passes, and we can calculate a lot of statistics. So, for example, we can say that Messi has completed these many passes in a game of in the game of football without having a human to count it manually. Or we can say these are the weak spots in the strategy. So machine we can identify like the weaknesses of a team using analytics. So all these big sports organizations, they have a team of computer vision engineers who actually help them diagnose the problems, diagnose the weaknesses in the team. Uh, Surveillance is another one uh, that you can actually, with all the data that's being collected by CCTV, it's very hard to process it, right? Because let's say you have data from which has like thousands of people in one frame. For humans, it might be very hard to identify what's going on. But with computer vision algorithms, you can actually efficiently identify the actions that are happening, the people, the objects that are there in the scene, and without humans having to do something, actually just get the statistics and labels directly. Then there's gaming. So there are so many innovations that have happened in graphics, and now we have all these new gaming experiences with Microsoft Kinect and Nintendo Wii, in which you can just move, and the with cameras and some sensors, the computer vision algorithms are able to identify what actions you're doing and actually emulate them in the game. So this is pretty interesting as well. Then there's augmented reality and virtual reality. I don't know how many of you have tried these 3D these augmented reality and virtual reality headsets. So they allow you to engage in gaming or some virtual trainings in a very uh, realistic manner in a 3D world. Then it's very useful for exploration. So in the recent times, uh, rovers such as Curiosity by NASA have been deployed on Mars, and they use very high-end cameras and sensors to capture the to capture what's happening on these planets and send the information back to the scientists. And computer vision is really helpful in, let's say, identifying certain types of rocks, certain types of artifacts on the planet. And now, in fact, you can even identify the material properties using cameras with some other sensors, such as uh, heat and laser sensors. And yeah, you would have to go deeper into this topic of space exploration. And obviously, our favorite Snapchat filters and Instagram filters. Uh, so they social media has seen a lot of applications of computer vision in the recent times. So yeah, all these filters with that identify your eyes, nose, mouth uh, with camera, they all use computer vision, latest computer vision research that's been happening in the past 10 years.